Hi folks, we're just starting, I'm going to flip this back, our transformations unit. So we're going to be looking at how shapes change and the math that goes behind them. So we're going to start out with some pretty basic stuff. We're going to build up into some more stuff. It's for those of you who are very spatially aware, this is going to be a super easy unit for you. For those of you like me who struggle with the spatial piece, we're going to have to work a little bit harder at it, but it is something we can learn and we can get really good at. Okay, so you guys have all seen this before. This is not new. You would have done it in grade 9, probably grade 8 too. So this should be a nice review lesson for you. So we're going to run through the coordinate plane. Sometimes it's called the Cartesian plane. Sometimes you guys might refer to it as a graph. What makes it a coordinate plane is that we have our axes. So the horizontal one is our x-axis. So let me, x-axis. So that runs horizontally. That tells us how many units that we move either right or left. Straightforward. Our vertical axis is the y-axis. And that just tells us how far we move up or down. And there's a starting point. The starting point is called the origin. Now this occurs at the point 0, 0. That means we've moved neither left nor right, and we've moved not up or down. We're just sitting at that place right there. So it's called the origin because that's where everything starts, right in that middle piece there. So that's kind of cool. For those of you who may not know, quadrant 1, it's a little bit weird, but quadrant 1 is where x and y values are positive. And we always lead with the x. So the x is positive and the y is positive. So those two things are happening. So this is always your x coordinate, that's always your y coordinate. So x comes first, y comes second. Now in quadrant 2, when we move over to here, all of our x values will be negative, but our y values will still be positive. In quadrant 3, both x and y are negative. And then in quadrant 4, x is positive, y is negative. And it seems a little weird, like why isn't, we read left to right, so why isn't this 1, 2, 3, 4? And the reason why, or the reason I think why, I don't know this 100%, but we start this in quadrant 1 because both x and y are positive. It's the one that we function in a lot of the time, especially when we're dealing with like real life quantities. We're not going to have negative time, we're not going to have negative distance, that sort of thing. So we do a lot of stuff in this positive quadrant. And when you were first learning how to graph, like way back in grade 4, you would have stayed here in quadrant 1 where everything is positive, both your x's and your y's. And as you got more math knowledge, then we started opening up things. So we start in 1, which is the upper right-hand one, and we travel in a counterclockwise direction. Feels a little weird, but that's how it works. All right. A little reminder that the coordinate pairs are always in the order x, y. We read left to right first, how far we've traveled either left or right from the origin, and then we look at how far we've traveled either up or down from the origin again. Okay, so we're just gonna kind of blow through this. This is stuff that you guys already know, and if you don't know it, it's something that you'll be using and something that you'll see all the time. Okay, so we're gonna look for point A first. So there's point A right there. Let me grab a different color. So there's point A right there. That one's a little bit hard to see. They're all kind of tiny. You can see the increments. When I talk about increments, those are the markers. What is each line? What is each unit worth? So this 1, 2, 3, 4, 5. If it's 1 unit this way, it has to be 1 unit this way. You can go up by 2s, you can go up by 3s, like you can get creative. Most times it's up by 1s. We're gonna look at our y-axis. So if I say, hey, your graph has to have increments, all I'm asking for is that you put what each tick is worth. Is it worth 1? Is it worth 2? FYI, the x-axis can go up by 1, but your y-axis could go up by 2s, could go up by 3s. X and y don't have to have the same increments, but you do have to have the same positive and negative increments on the same axis. Okay, I'm rambling. Let's get to this. Okay, so A is right on this y-axis. So I'm looking for, I always start at the origin. How far right or how far left did I go? Well, I didn't move. I'm still stuck at this spot. I didn't move left or right. So we would say that our x value is 0. Now we're looking at how far we've gone up. So if we're starting at the origin again, we're going to count how far we've gone up. 1, 2, 3. So we've gone positive 3 up. So my coordinate pair is 0, 3. Now we're going to continue to do this. So B is over here. There's B right there. So we're going to look at this. So we're going to go left or right. B is definitely right at the origin. So B is 1, 2. Okay, I'm 2 units away from the origin. So my x, and I'm moving in a positive direction. Right is positive, so it's going to be a positive 2. Now at the origin, when I look how far down I've gone, 1, 2, 3, 4. So I've gone down 4 units. And you're like, but that didn't get you to the point. You can do it this way. You can travel over 2. So we've traveled to the right 2. So there's my 2. And then we're traveling down 4. And if it's down, that means it's at negative 4. So over 2, down 4. It's kind of like the game Battleship. If you've ever played that or done mapping on an atlas, you know, you're at A2, so you go over to A, down to 2, and the country should be, or the city should be within that block. It's the same sort of thing. CNC machines, so your laser etchers, your plasma cutters, things like that, they all work off a grid system, just like this. So if you're going to do any programming for that, knowing your x and y axis is super important. Okay, I'm going to get faster at this, but I want to take some time. Okay, C is right here. So C, oh look, it's in line with B. So I know I'm going to the right 2, so positive 2. And this time I'm traveling up, so 1, 2, 3, 4, up. All right, so they both have a positive 2, but one is below the x-axis and C is above the x-axis. D is over here. Sorry, these are just really small, so I'm circling them just so you guys can see them on the graph. So D, start at the origin, and D I'm traveling over 1, 2 units to the left, so left is negative. Just like a number line, right? So all the pieces of your math are coming together. And then we're going down 1, 2, 3, 4. So again, down is negative. All right. E is sitting on the x-axis. So we start at the origin, and we have moved 1, 2, 3 to the left. So that's going to be a negative 3. But we haven't moved up or down from the origin. So that means we've traveled 0. So we haven't moved up or down, which is okie dokie. There's nothing wrong with that. E, now we're moving on to F. Anybody see an F on here? There it is. Whew, my eyeballs. All right, so there's F. Same sort of thing as A. We didn't move either left or right off the origin, so my F x value is 0. But I have moved 1, 2, 3 down, so that's going to be at negative 3. So once you get the hang of it, it goes a lot faster. G is over here. G is really similar to E, but we've moved in the opposite direction. So if I'm starting at the origin, remember I always go left to right first, so 1, 2, 3. So 3 to the right is positive, and then I've moved neither up nor down, so I've stayed in place, so that's going to be 3, 0. H is, okay, so I got to read left to right first, so I'm going left from the origin, always starting at the origin, so 1, 2, So 2 to the left, so that's going to be a negative 2. And then I've gone 1, 2, 3, 4 up. So up is positive, so that's going to be negative 2, 4. All right, we're down to our last 4. I is over here. All right, so I is over here. So left to right first. So start at the origin. 1, 2, 3, 4. So 4 to the right, so that's positive. And then I'm going 1, 2, 3 up. Now I don't know if you guys noticed this. I is in quadrant 1. Both are positive, but we knew that. We knew anything in quadrant 1, both x and y will be positive. And like I said, the more you use this, the more comfortable you're going to feel with it. Right now, if this is your first time doing it or your first time remembering doing it, it can be a little bit like, okay, I got to count it out. So again, start at the origin. This time I'm going left 1. So if I go left 1, that's a negative 1. And then I'm going to go up 1. So I'm moving up into the positive. And we know that anything in quadrant 2 will have a negative x and a positive y, which this point did, which is kind of cool. So if you're unsure, you can always go back to this little handy reminder of what's happening in each one. So C, I will all be positive. H, E, J will have an x negative and a positive y. And D in this one, D and L, we haven't got to L yet, but D and L, we know they're going to be both x and y will both be negative. And we know that B and K here, they will both have an x positive and a y negative. So just, you know, like it all kind of ties together. If that's confusing for you, just forget it. Pretend I didn't say it. Okay, so now we're looking at K. So K is right here. K is in quadrant 4. This is quadrant 4 down here. So I know I should have a positive x and a negative y. So if I count over 1, 2, 3 to the right, so to the right is positive, and then I'm going down 1, 2, 3. Down is negative. And notice I'm putting brackets around everything. Coordinate pairs always have brackets. I didn't mention that, but it's a thing. All right, last one, L. Okay, so I'm just gonna, this is how I do it. Okay, negative 4. Okay, see my negative 4. Drop my finger down, run it over. That's gonna be at negative 4. So that's how I do it to do it quicker. Whatever works best for you guys. I think finding a strategy that you feel comfortable with is the most important thing. Okay, so that's that. Holy Hannah. Okay, there's more on the back because that's who I am as a teacher. All right. Okay, we're going to plot the following points. So this time we're doing it differently. I've given you coordinate pairs and you have to drop them on there. Well, we're going to drop them on there. So 2, so I'm going 2 to the right and 4 up. That is point A. So I'm going 2 to the right and 4 up because these are positive. So 2 to the right, 4 up. Looking at this, I know if it's a negative then a positive, I know it's in quadrant 2 because I know all coordinate pairs in quadrant 2 will start with a negative and have a positive for the y. Just if you're wondering where things are. So let's do B. So again, start at the origin, go over to negative 4, and then we're going to go up to positive 3. And that's where I draw my point. So that's point B. All right, C is a positive x and a negative y, so I know I'm in quadrant 4. So start at the origin again, go to the right 5, and down negative 1, which is right there. That's where I draw my point. Okay, I don't draw a point at 5, where, oh sorry, my big fat finger's in the way. I don't draw a point at 5 because I still have to go down that negative 1. So my point C is below the x-axis. All right, D, 0, 1. Okay, so 0 means I move neither right nor left. I stay right where I am. And then I'm going up 1. So that is point D. -6, -5. I know if they're both negative, that means I live in quadrant 3. So those sort of things. All right, so E is -6, so I start at the origin. I go over to the -6, and I go down 1, 2, 3, 4, 5, and that's where I draw my point for E. All right, so I'm going a little bit faster here. If this doesn't feel comfortable with you, pause the video, take a minute, look at the notes later, see if you can do it on your own. So this one's -1 and 0. So this tells me I'm moving 1 to the left, but the 0 tells me I'm not moving up or down. So my point is right there, and that is the letter F. Now the last one, G, is a very special point. That's 0, 0. That is right here, and that is what we call the origin. So if you ever see 0, 0, you know you're at your starting place. Okay. Like I said, not hard, but does take some practice. I've been doing it for a little while, so you know, I go through it pretty quickly. I found a strategy that works for myself. I think you guys should too. Okay, so this one we're drawing a shape with the vertices. Vertices is the fancy math word for corner. Okay, fancy math word for corner. So we know that this shape has 4 corners. All right, so I got -5 and -5. So 1, 2, 3, 4, 5. So I'm going to drop my point here, A. B is at 0 and -5. So 0 tells me I don't move left or right, and I just go straight down to -5. That's B. C is at 6 and 4. 1, 2, 3, 4. That's C. And D is at 1, 4. Ooh, I kind of went fast there. And you guys are like, that doesn't make a shape. Those are 4 dots. So when we're trying to make a shape, we're going to go from point to point. I'm going to connect the dots, just like we used to do on those sheets, A to B. So I'm going to grab my ruler. I'm going to connect those 2 dots. Then I'm going to connect B to C. And some of you won't use a ruler, but again, I'm not really good at spatial stuff. So I'm going to use a ruler just to help my stuff look good. So C to D. And then we're going to go all the way back. We're going to connect D to A. All right. And what shape is formed by these 4 vertices? I hope you're all yelling out that it is a parallelogram. I don't know if you guys noticed, but this is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. These have the exact same length. We can do that with Pythagorean theorem if we want to figure it out. But we can figure out the slanted sides of it. But you're going to trust me that it is a parallelogram. See, if I sound it out, I might have a shot at spelling it. If you don't have any hot sweet clue what shape it is, go back to our very first unit on area and perimeter, and your shape pictures are in that one. Okay, skill testing question. What quadrant, so remember that this is quadrant 1, this is quadrant 2, this is quadrant 3, and that's quadrant 4. And I have no idea why they use Roman numerals to label the quadrants. If you don't like those, that's okay too. But I just want you to see them and recognize what they are. They're just Roman numerals. It's a fancier way of counting. Looks a little different than our Arabic numbers. Okay, so what quadrant is the point -3, 5 in? I know, so, well, one, you can do this really easy. You can drop the point on. So -3 is here, +5 is here. So I'm in quadrant 2. But that was handy because I had a coordinate plane. I had the Cartesian plane right here, so it was easy to do. If I didn't have this, if this was gone and this was just a question on a quiz and I had no idea what to do, I know in quadrant 2 that all x values will be negative and all y values will be positive. So I know it has to be in quadrant 2. Again, I've done this for years. It makes sense to me. But yeah, that's it. Plotting points. Today you're going to make some shapes of letters, and it's going to be magical, and you're gonna have a great time. Okay, good luck. And if you have any questions, let me know.